Okay, so this problem was tripping a lot of students up in my class, and so I kind of want to cover it a little more in detail and help you guys out. So the standard that you're trying to meet is Kentucky HSG 24. Use coordinates with a coordinate plane to calculate measurements of two-dimensional figures. You're trying to compute the perimeters of various polygons and compute the area of triangles, rectangles, and other quadrilaterals. Okay, so that's the standard, and let's talk about what's going on here. So you'll see you've got an XY coordinate plane here. And what you should notice is that the points are clearly defined, and we want to kind of lay out a goal for you. So the goal is to, in this case, in this example, is to find the area using the distance formula. Okay, so in this case, our shape is a triangle. So if you've forgotten the area of a triangle, area is equal to 1/2 times the base times the height. So really what we have to do is find the base and the height of this triangle, and then we're good. That's all we have to do. So we're going to start out, and so I'm looking at this figure, and what's popping out to me as the base is AB. Okay, so I can rewrite this formula down here, right? Area is equal to 1/2 the base times the height. Well, the base is going to be the length of AB, okay? And then the height is going to be this length right here. So it's the distance from the base to the peak. So that's going to be times DC. So really, if I can find the value of AB and DC, I've got the problem down. All I have to do is multiply from there. And it's relatively easy if you are pretty familiar with the distance formula, okay? So we're going to start this out, and what we've got here is we've got AB, and we know that it's going to be the change in x squared plus the change in y squared. And we've got the points A. They give us that A is -6, 4, and B is 6, 7, okay? So what I can do is I can look on this number line, and I can see where -6 and +6 are in relation to 0. So I've got 0, 6 is over here, -6 is over here, 12 is in between, and this is what I've got. The distance from -6 to +6 is 12, so that means delta x is equal to 12. So I'll just have to plug that into the formula. Only thing left to find is delta y. And so delta y is going to be the distance from 4 to 7. So I've got 0 here, 4 is over here somewhere, and then 7 is over here somewhere. So the distance from 4 to 7 is going to be 3. Okay? So what I can do is rewrite this formula and just solve it out. So I've got AB is equal to the square root of 12 squared plus 3 squared, which is going to be the square root. 12 squared is 144. Let me write that a little cleaner. (144) plus 9, which is the square root of 153. And so I'm done with that. Now all I have to do is find the distance from D to C. Okay? So I've got that, so I can plug that into the formula here in a second. And so I need to find the length of CD. And CD is going to be the same thing. Its change in x plus its change in y squared. So delta x squared plus delta y squared. And I've got that C is 2, 6. And if you're wondering where I'm getting these coordinates, it's from up here. So C is not 2, 6. It's 4, -2. My bad. But it's going to come out the same. So C is 4, -2. And D is 2, 6. Okay, so all I'm trying to do is find that distance. And so I've got the two x values that I'm trying to find. I'm trying to find the distance between 2 and 4. So here's 0, here's 2, here's 4. So the distance between those two is 2. And then I can do delta y. So I've got zeros here, -2's over here, and then 6 is over here. So the distance between those two is 8. And so I've got delta x is 2, and delta y is 8. So I can plug those two values in for the formula for CD, which this is just a rewrite of the distance formula. It's an easier way to do it. So I've got square root of 2 squared plus 8 squared, which is the square root of 68, because 8 squared is 64, 2 squared is 4, so 64 plus 4 is root 68. So now all I have to do is plug that into that formula. So I've got area is equal to 1/2 AB times AB, the length of AB, times the length of CD. And we just found AB to be root 153, so 1/2 times root 153 times CD is root 68. And now all I have to do is type that into my handy dandy graphing calculator. So I've got, if it'll work today, it's broken. What did I do? What have I done? Oh well, do an edge too. Go to Google. And I can beg Google for the answer. It's going to be 1/2 times the square root of 153 times the square root of 68. If I'm lucky, come out nice, and it didn't. It's 51. So that is equal to 51. And I'm done. That is all I was supposed to do for that one. And then perimeter is going to be very, very similar. So whatever your object is, right, I found that this was root 153. To find the perimeter of the object, all I'd have to do is calculate this distance and this distance over here and add them up, right? Because distance is like, if this is my yard, if this is my yard, this entire thing is my yard, then the perimeter would be the fence around my yard, okay? The length of all the fences added up, okay? So that's one way you can think about perimeter. But that is it, and I hope that helps. I hope that makes it a little more clear on what you're doing. Little small problem. Didn't take too long, didn't take 30 minutes. I like these little mini lectures, and we're good to go.